Welcome students. Now we are going to see the major defects in the metal forming process. So we are going to see the major defects in the metal forming. So all together we are going to see the defects, okay, for extrusion, forging, then rolling, all together we are going to see. So let us see the first defect, which is called as the bamboo defect. So what is bamboo defect? So here the cross section of the extruded part will have the structure like a bamboo stick. It will look like this. It will look like this. The cross section of the extruded product will be like bamboo stick. Okay, so this is like a bamboo stick. So this defect is called as the bamboo defect. So because of the non-uniform velocity, non-uniform ram velocity, this defect is going to occur into the extrusion process. Please remember this. Now the second defect we are having the pipe defect. The pipe defects. The pipe defect is what? This is because of non-cleaning of the billet material. Billet material is non-clean. So what happened? So in this direct extrusion, say for example I am taking this is the ram and we are applying the force. So this is the billet material, isn't it? So if the billet material is not properly cleaned, so what is going to happen? So suppose whatever the oxide layers or some scale which is present onto the surface of this billet material will flow and cause some small voids or small blowholes at the center of the extruded part. So this is nothing but the pipe defect. Okay, so we have to clean the billet material properly before placing it into this closed rigid container. Okay, then the third defect that we are having, that is the center burst. This is the center burst. Generally the center burst with the too large deformation gradient along the cross section. So for example we are having the alpha value. Alpha is what? Our half the die angle, isn't it? So this is our angle alpha. When we are having the large angle alpha and relatively low reduction ratio, that is, suppose this is the height h and this is the length of this conical portion, that is L. So high alpha value, high alpha and low reduction ratio is nothing but what? The large h by L ratio. So in this situation what is going to happen? There will be the large deformation near the surface of this die. So that is nothing but we are having the localized deformation near the surface because of this thing, a large value of alpha, low reduction ratio, or the large h by L ratio. There is the deformation. There is large deformation, or this is the localized deformation. Localized deformation near the surface. But see, we are having the localized deformation near the surface of this die, but what is about the central portion? So what happened? The central portion of this material relative to the surface material is not having that much deformation. So it is having relatively smaller deformation compared to this material which is at the surface of the die. So what happened, this upper layer of the surface is simply dragging out this central portion of the material, isn't it, into the die, and the result of this, there are chances of the secondary tensile stresses are getting developed, and because of that the center burst is going to produce. So what happened, so as the localized deformation there, so central portion have relatively small deformation, so which will dragged by the top layer or the surface layer, the top layer into the dragged out, simply I can say dragged out by the top layer. And this is the reason why there are the development of secondary tensile stress, and which will cause the center burst. Suppose this is a product which is coming out, so this is the center burst, which will observed in the, say this is a wire drawing die, so same fashion it can be developed in the extrusion process. So again in extrusion process the chances can be get minimized by using this H/L ratio less than 2 in case of the extrusion. So this is kind of, say, again this is a defect at the center of this extruded product. We are having the crack or the crack like things. This is nothing but the center burst. Now the next defect we are having, again in case of the extrusion only I am talking about the fishtail. The fourth defect we are discussing, the fishtail. These are again the cracks at the center of this extruded product, but it will look like the fishtail. Okay, so actually these are looking like this. So this is the fishtail defect, cracks like this. So fishtail again is a defect in the extrusion process. Okay, so fishtail, center burst, pipe defect, bamboo defect, these are related to generally extrusion, but please remember center burst is the defect which are normally seen in the wire drawing operation also. Then the defect we are having in the rolling operation I am talking about, say alligating, or it is known as the crocodile crack. So generally when we are using a thick slab in the rolling operation, so what is happening there, the sheet or the slab is getting splitting into two halves. Okay, so like this thick slab is going to split into two halves. See, so this is nothing but call it as the crocodile cracks. Okay, so this is one of the major defect in the rolling operation. Again, see, there are the defects due to the irregular surface, then the scale or oxide for layer present onto the surface of the rolling sheets. So these are actually then the inclusions we can say. So these are the sources of the defects which are get generated into the rolling operation. So one of the important defect that is we are knowing as the anisotropy in the rolling operation is caused because of this scale which is present onto the surface. Okay, so these are the sources of defects in the rolling operation. Now if you talk about the zipper teeth, so say this is a rolled part, so we are having the the marks on the rolling sheet or such kind of cracks. So these are nothing but the zipper cracks or zipper teeth like cracks. Okay, then there is also possibility of wavy edges that we are going to get after the rolling operation onto the sheet, right? Wavy edges, then zipper teeth cracks. Okay, so these are the rolling defects. Now if you talk about some important forging defect, so we are having eighth defect, that is cold shut. So what is cold shut? So these are nothing but the cracks which are developed at the corners of the forged part, the cracks at the corners of the forged parts. So this is nothing but the cold shut. So this is because of the improper design of the forging die. So this is very important thing. This is because of the improper design of the forging dies. This is main thing. Then we are having the improper flow. This is also one of the defect in the forging operation. That is, see, if some of the part in this die cavity in the forging operation is unfilled, okay, it's not filled completely, then this defect is known as improper flow of the material. So again, this is because of the wrong or poor designing of the forging die, and this is because of the improper or wrong forging techniques. So that is why this improper flow is get caused in the forging operation. Also there are the improper flow of grains. This is also one of the major defect in the forging operation. That is, if you want the required orientation of the grain, but in the product at the final stage when you get it, the orientation of the flow of the grain is not as we want. Okay, so that is again we are having like improper grain flow, grain flow. Then one more important defect that we are observing in the forging operation, that is scale pits. So what is the scale pits? Suppose if your billet material or raw material which have you taken for the forging operation, so if there are the scale or inclusions are present onto the work surface and you are done with the forging operation, so what happened, this scale or that dust or that inclusion get embedded onto the surface of this raw material. Okay, and once the forging is over, when you are cleaning with this oxide layer with the pickling or acid cleaning, so what happened, so these particles are get out, but the impression of these inclusions or this scale is left onto the surface. Some small depressions we can see or some pits you can see, that is known as the scale pits in the forging operation. Okay, so this is also again very important defect in the forging operation. So see, we have talked about the extrusion defects, then we have talked about the rolling defects, then we have talked about the forging defects also. So these are certain major defects in the metal forming operation. Okay, thank you.